Riggers must often hoist materials and equipment in situations where it is not practical to use a crane. The load may be too small to warrant a crane, or there may be insufficient headroom for a crane to operate. The rigger has a wide variety of lifting devices available for such jobs. This session covers the safe use of anchorage points, chain hoists, lever-operated hoists or come-alongs, grip action hoists, electric wire rope and chain hoists, pendant cranes, and base-mounted winches. Although all the equipment covered in this session has a rated capacity, the strength of the attachment points is often not taken into account. Whatever the equipment is anchored to becomes a part of the hoisting system. A safe working load with an appropriate factor of safety must be established for the anchorage. The required factor of safety is 5 for general hoisting, 10 for hoisting personnel, and 3 for horizontal poles. Often the point of attachment is on a beam or column. If the member is an I section, it should be loaded so that the force is in line with the web at 90 degrees to the flange. In general, I sections are much stronger in this direction than this direction. Make sure that the load will not impose any twist on the member, because in most cases, members are not designed for it. Beam clamps are a reliable and convenient means of attaching equipment to I sections. Available in a number of sizes to fit various flange widths, they each have a rated safe working load. A variation on the beam clamp uses wheels that run on the flange, allowing a hoist to trolley along the beam. These can be adjusted to fit a wide range of flange sizes and, like the beam clamp, have a rated safe working load. All trolleys and most beam clamps are designed for loading at right angles to the flange only. Their location on the member is critical. In most cases, it is best to locate the anchorage point near a support or at the base of a column. The ability of the beam or column to withstand the additional load depends on the unsupported length. The load's already on the member, the size of the member, and the direction of loading, to name a few factors. The main point to remember is that the safe working load of a beam clamp applies only to the fixture itself and not to the structure it is attached to. The most common method of anchoring equipment to a structure is a sling lashed around a member. The sling is usually wire rope, but nylon web slings are often used on pipe or finished surfaces. Choose a sling with enough length for a double wrap on the member and attach the equipment to both eyes. Use softeners on edges to avoid damaging the sling. It is good practice to select slings at least one size larger than the load would normally require. This allows for the loss of efficiency caused by sharp bends in the sling. Another common method of attaching rigging equipment to a structure is to weld a lug, usually a plate or angle, to a member. All too often, a piece of scrap is picked up off the floor, a rough hole is blown out of it, and then it's haphazardly tacked to the structure. Instead, the hole should be drilled or at least flame cut and ground. The lug should be welded on the center line of the flange in line with the web. Make sure that the lug is long enough to allow sufficient weld for the required strength. The weld should be inspected by a competent person before the lug is used. Whatever the method of attachment, it is important to realize that the structure is usually not designed for the additional loads you will be applying. The only way to be sure is to have the situation evaluated by a structural engineer. Chain hoists, also known as chain falls, are hoists operated by a hand chain which engages a system of gears to raise or lower the load chain. Chain hoists should be used in a vertical or near vertical position only. Otherwise, the chain will jam in the chain guides or at least cause accelerated wear on the chain guides and chain. A straight line must be maintained along the hoist chain between the upper and lower hooks. Chain hoists are designed so that one person of average strength can exert enough force on the hand chain to load the unit to capacity. If the operator cannot lift the load by himself, then the hoist is overloaded. Some manufacturers provide hoists with a type of clutch that will not allow an unsafe load to be lifted. However, this safety feature does not affect the lowering of the load because it takes less hand chain pull to lower the load than it does to raise it. Before using a chain hoist, make sure that the chain is not twisted and that the hooks swivel freely. Twists can damage the chain guides and lift wheels as well as the chain itself. Hooks should be measured for signs of opening up. If the hook has opened up, it has been overloaded and should be replaced. Both hooks should be equipped with safety latches. If the hoist chain requires replacement, follow the manufacturer's recommendations. The hoist chain of a chain fall should never be used as a sling or bent around corners, as this can bend or stretch the chain. Chain falls should not be used to support loads for any lengthy period of time. The lever-operated hoist, generally called a come-along, is a hand-operated hoist that can be used for straight-line pulls in any direction. Come-alongs are commonly available in capacities ranging from 1/2 ton to 3 tons. Most use chain to transmit load. Like chain falls, a properly rigged come-along must always be loaded so that the pull is in a straight line between the hooks. This ensures that no additional stress is placed on the unit other than the load itself. Unlike chain falls, come-alongs can be used horizontally or on an angle. Often an operator will increase the force applied to the come-along by adding a length of pipe or cheater to the handle. This hazardous practice will lead to overloading and complete failure or irreparable damage of the hoist. Use a larger capacity come-along when you cannot move the load without a cheater or the help of another person. Grip-action hoists, commonly known by the trade name turfer, are useful for long lifts or pulls since they act on a continuous length of wire rope. They can be used with snatch blocks to change the direction of pull. The most common type of grip-action hoist is operated by 2 levers, one for forward motion, the other for reverse. The levers operate 2 jaws, which alternately grip the rope and draw it through the unit. These hoists can only be used with galvanized, unlubricated wire rope, designed especially for use in these machines. No other rope should ever be used. Turfer ropes require careful handling to ensure that they do not kink. Kinked rope will jam in the gripping mechanism and prevent the rope from passing through the hoist. Rope damage can be minimized by using reels to take up and store the rope. Electric chain hoists are similar in operation to the come-along and hand chain hoist, except that an electric motor powers the chain more rapidly over the lift wheel. Because of this increased speed, limit switches are necessary to prevent the chain from over-traveling, either up or down. The upper limit switch should be set so that the hoist shuts itself off with several chain links between the hook shank or lower block and the hoist body. The lower limit switch should be set so that the hook cannot touch the floor, or higher to allow for the height of the load. Only qualified personnel should make adjustment to the limit switches. Be sure that the hoist is wired properly so that the direction of travel corresponds with the controls. If the unit is running in the wrong direction, consult a qualified electrician. Many electric chain hoists manufactured today are equipped with overload protection that will not allow the hoist to attempt a load greater than its capacity. The electric wire rope hoist is similar to the electric chain hoist, except that wire rope is the lifting medium, and the wire rope wraps onto a grooved drum. When operating an electric wire rope hoist, be sure that the wire rope is feeding onto the drum properly. Otherwise, lifting capacity can be compromised and the wire rope severely damaged by crushing. Electric wire rope hoists are usually outfitted with an overload protector and upper limit switches. Pendant cranes are sometimes available to construction crews modifying an existing structure or building a new facility in which the crane has already been installed. These cranes take their name from a handheld pendant which controls their operation. The cranes should not be used in a new building until they have been equipped with all safety devices, including rail stops, limit switches, and overload protection systems. Before operating a pendant crane, make sure that all controls and limit switches are functioning properly. Warning devices, limit switches, and other safeguards should never be bypassed. Whenever the operator does not have a clear view of the load and its intended path of travel, a signalman must direct operations. Signals for pendant cranes are different from those for mobile and tower cranes, since machine movements are different. Make sure that everyone involved knows the signals required for this type of crane. Base-mounted winches or tuggers are used in a variety of construction applications. They may be used for vertical lifts, horizontal pulls, or lifts up an incline. They may be powered hydraulically, electrically, by compressed air, or by gasoline engines, and use either wire rope or fiber rope. To select a winch for a particular application, riggers must consider a number of factors. The most obvious is capacity. Winches are given 2 ratings by the manufacturer. One for horizontal pulls based on a factor of safety of 3, and a reduced capacity for hoisting based on a factor of safety of 5. Other factors include the diameter and length of rope required, which determine in turn the diameter and length of the drum. Rope speed is another factor which must be considered. In general, rope speed will decrease with increasing load and increase with the amount of rope on the drum. If rope speed is not sufficient, a larger winch is required. All winches should be equipped with an automatic brake. If power to the drum is interrupted for any reason, the brake will engage automatically and prevent the load from dropping. If possible, select winches with controls at the side for the operator's safety. Keep all unnecessary personnel out of the area during winching operations. It is a good idea to rope off the area and post warning signs to prevent accidental entry into the area. Many winching operations require the direction of pull to be changed by snatch blocks. It is vital that you understand the forces exerted on these blocks. Many accidents have been caused by block failures during winching. If a block is used to change the direction of pull by 90 degrees in a line carrying a 1-ton load, the resultant load on the block and its anchorage is 1.4 tons, neglecting friction. A change of direction of 135 degrees will result in a force on the block of 1.85 tons. A 180-degree bend will create a resultant load of 2 tons or double the line load. Always keep this in mind and choose your block and anchorage accordingly. Winches should be installed so that the line leaves the drum parallel to the ground or at a downward angle. If the hoist line leaves the drum at an upward angle, the line pull will tend to lift the winch off the ground. To avoid this, insert a snatch block in the tackle system some distance away from the drum to change the direction of pull. Equally important is the placement of the winch in relation to the first sheave or snatch block the rope passes over as it leaves the drum. The center of the drum must be directly in line and square with the first sheave. As a general rule, the first sheave or snatch block should be 15 drum widths from the winch so that the rope winds on the drum evenly. Let's look at a few general guidelines for the rigging equipment covered in this session. Inspect the full length of chain and wire rope on rigging equipment. Check chain for wear, gouges, and bent links. Check wire rope for kinks, broken wires, and signs of wear. Replace worn or damaged wire rope or chain immediately, or remove the unit from service. Make a load test by lifting and lowering the load slightly. This will indicate whether the unit is working properly. Stand completely clear of the load at all times. Don't allow any part of your body or a fellow worker's body under the load. All hoists should be given a rated load test after maintenance. Make sure the devices operate properly and will lift and lower a capacity load. Lubricate hoist chain and wire rope regularly. Do not lubricate to the point where the lubricant runs. Turfer rope does not require lubrication. Replace load chain with case-hardened alloy chain supplied by the hoist manufacturer. This will ensure that the chain fits the lift wheels properly. Never use the wire rope or chain on a hoist as a ground for welding. Here are a few points to remember about the equipment covered in this session. When using any of this equipment, make sure that the attachment point has sufficient structural capacity to support the load and hoist. If there is any doubt, consult an engineer. Always use the proper capacity hoist for the job. Remember that manually operated hoists are designed to develop their full capacity under the applied force of one person only. Do not use extensions on handles. Inspect the hoist before you begin to lift any load. Make sure that the hooks and other end attachments are in good shape. Never use the load chain or hoisting rope as a sling. Come-alongs and chain falls must be rigged so that the pull is in a straight line between the two hooks. Any electric-powered hoist should be checked to ensure that limit switches are working and that direction of travel corresponds with the controls. Make sure that everyone involved in a lift with a pendant crane is familiar with the signals. Keep the area around winching operations clear of unnecessary personnel. By now, you should be familiar with the basic operation of hoists, pendant cranes, and winches, as well as the need for secure anchorage points. Further information is available from your Construction Safety Association of Ontario.